Hello, my fellow researchers, and welcome to part 3 in our binary logistic regression example. And we're still trucking along, going through our output. And in this video, we're going to be focusing on the output as it relates to our significance of the model and the variance with which our model explains. And so for our significance, we're going to be looking at chi-square. Okay, and so in this table here called omnibus tests of model coefficients, we have 3 columns: chi-square, degrees of freedom, and our significance value. And so in your report, you're going to want to describe the significance of your model, and you're going to do that with chi-square. So this is the chi-square symbol. Okay, and immediately after you put down the chi-square symbol, you're going to include your degrees of freedom, which in this case is 5, and you can see that from this column right here. And then immediately after that, you're going to include the sample size, and we know our sample size is 120. Again, you can always go and check that again if you forget. Then finally, we're going to actually write down the chi-square value, which was approximately 52.14. And finally, you're going to throw a little comma in here, and you're going to show the probability value. And in this case, we're just going to write p is less than 0.001. Okay, you can see in this column here, it says p is equal to 0.000. What that means is that it's just less than 0.001. Nothing is 0.000 to infinity. This is just how we report it when SPSS gives us that value. Okay, so keep that in mind. And again, omnibus tests of model coefficients gives you all of this information right here, and this is critical for your report. In this model summary table, okay, we have 2 values of importance. Okay, Cox and Snell are square, and Nagel-Kirky are square, and you'll remember the term variance. Okay, variance, and you might remember R. Okay, and then you might remember r squared. And we're looking at r squared in this example. That's what these values are. And so in your report, you'll say something like between 35%, and that comes from the first number, between 35% and 47, whoops, the hell? Okay, 47% of the variance, okay, is explained by our independent variables. In words, okay, between 35% and 47% of the variance in the dependent variable is explained by our model. Okay, so we have a dependent variable, right? Dependent, and then we have a number of independent variables. In this case, we have 3 of them, right? And we're saying that between 35% and 47% of the variance in our dependent variable is explained by our model. Okay, and that's pretty good. That's very good. Again, our data was all hypothetical, but if you were to achieve these values in the real world, you'd be pretty happy with your model. And the last thing we're going to look at here is the Hosmer and Lemschau test. And you'll probably want to report this test as well. This is a very strict test. And actually what we're looking for here to support our model is an insignificant value. Okay, so you can see right here, we have p is equal to 0.053. Okay. Now, if we consider values less than 0.05 to be significant, then this current value of 15.336 for our chi-square is insignificant. Okay? It's insignificant, and that's good. That's what we want. Okay? So let me just insignificant values. Insignificant values. Oh my god. Pardon me. Values. There we go. Insignificant values where p is greater than 0.05 are good. I know I'm writing like a child here, but please forgive me. I'm using this Wacom tablet. Sometimes it's difficult. So that's critical, okay? Because you want to remember the omnibus tests of model coefficients. You want a significant value. That's good support for your model. But for the Hosmer and Lemschau test, you want an insignificant value. That's good support for your model. Okay? So in this case, you would report that we received an insignificant value on the Hosmer and Lemschau test, and you could also show the chi-square similar to how we did up here. So that's all we're going to talk about today in this video. And stay tuned for the next video where we'll be going over the rest of our output. And there's only 3 more tables left to go. Thanks for watching. Stay tuned. Cheers.